situated?
Dublin, so it's 8 p.m. here.
Oh, wow.
Same
Yeah.
here. We're in the same time zone. I'm in Portugal.
Oh, wow.
Oh, you're Portugal.
Yes, it's really nice here. Although today was like the first autumn storm, so it's like insanely cold and windy now. But it's the first day I haven't been on the coast.
Sounds wonderful. It has been raining here for the last 4 days.
No.
What about you, Ethan?
I'm based in San Francisco, so it's noon here, and much better weather than for you two. Last week it was in the 90s, or I don't know, close to 30 degrees Celsius here.
I don't know, dude. I don't think that sounds great. My AC bill would be so high. That's fair. Well, how are the fires, by the way? Are they, thanks to COVID, time really doesn't exist anymore. So, is it clear? Like, is the recovery process started?
Well, I mean, there's still fires all up and down California. The smoke in San Francisco and the Bay Area is, like, the air quality here is good. So the smoke is not necessarily affecting daily life. I think the wind patterns changed. There's a particular time of year due to ocean currents, et cetera, where the winds from the mountain west actually blow out to sea. So you end up getting this phenomenon where you get winds coming in from the sea and you get winds coming in from the west, and then you basically get kind of a lull in the valley, and smoke will settle in. It's kind of interesting to actually see the wind patterns as they change throughout the year, but there's a particular time of year in which the smoke can be really bad in the Bay Area.
Okay. Yeah, I have a friend living around there, and he was a few weeks ago. He was kind of scared with how everything was going.
Yeah, I mean, it hasn't been exactly pleasant. There was like the orange haze here for a few days, and then we went up to southern Oregon where they had the major fires that kind of razed towns. So we saw that and saw the devastation. So it hasn't been exactly a very good fire season in the western part of the United States.
Is there such a thing as a good fire season, though?
Yeah, when there's no fires.
Okay. The absence of fires. Okay.
Yeah.
Okay, cool. So I guess we shall start then. So hello everyone.
Sorry.
So welcome to the pydata API Quirkshop. My name is Lais Carvalho, and I will be hosting this Quirkshop today from Dublin, Ireland. I'm a developer advocate, an open source enthusiast, and also a nerd. Surprise, surprise. I'm a volunteer for the EuroPython Society. I helped organizing the conference, the online conference now for this year, and we're currently organizing EuroPython 2021 that is also going to be online. Thank you, COVID. So I also helped hosting a few meetups around. So I was responsible for the organization of pydata Dublin for this summer. I'm also a board member of Python Ireland and an organizer of Pyjamas, a 24-hour worldwide conference when you can present wearing pajamas, another Python conference, but with pajamas this time.
Awesome.
Yeah, you should have actually know the CFP is closed. But you should definitely come and watch the talks. Yes. I'm very, very, very excited to be here talking to you today about this PyData APIs because, well, I think it's a great idea because of the amount of the amount of platforms and ways of people doing things with data with Python and data at the moment. It's extremely necessary to standardize everything. But then I had loads of questions. And then when Tony had the idea of hosting something like this, he just emailed me. He's like, you have to come. So to answer all my questions, or maybe a few of them, I have here today with me Ralf Gommers. Welcome. And Athan Reines. Well, welcome both. Would you like to introduce yourselves? to everyone that is here, you're listening to us tonight.
Yeah, thanks, Lais. So I'm Ralph. Let's see, where do I start? I'm a physicist by training. I have been a maintainer of NumPy and SciPy for almost 11 years now. And let's see, I've been on the NumFocus board for 5 years. And as a side project, fun project, I do PyWavelets still, which is nice. I've also contributed to a whole bunch of other projects. And right now I'm at Quantite, where I lead Quantite Labs, which is an open source lab where we try to support many projects, mostly centered on the pydata ecosystem. So everything from NumPy to Conda Forge to Jupyter to Dask to you name it. And we try to also do more than only write code. So we have people doing graphic design, UX design, community building, technical writing, a little bit of everything. So that's me.
That is so cool. Cool, thank you. And then Athan, would you like to tell us a little bit about yourself?
Yes, of course. Hello, everyone. I'm a software engineer at Quantite. As part of the consortium, I'm involved in writing the API specification and building tools which allow us to make, hopefully, better data-informed design decisions. And in a former life, I earned a PhD in biological physics, where I implemented and applied machine learning algorithms to better understand individual DNA-protein interaction in real time. That's kind of me in a nutshell.
I did not know about the DNA protein with machine learning. That is very cool.
Yeah, I initially mucked around a lot in MATLAB, and then at some point during my PhD, I started moving my lab over to using Python and non-proprietary software platforms. That was my pathway into Python.
Isn't that how we live was? We just
yeah, pretty much. Yeah.
Everyone kind of starts like this. Yeah, I started with MATLAB as well. Actually, I started with Wolfram Alpha, trying to understand how, trying to calculate my integrals when I was doing engineering, and then that didn't work out that well. And then I went into MATLAB for thermodynamics, and it also didn't work out that well. And then finally, I found Python.
Nice. But you and I stayed, and Athan left again. He's more down person now.
Yeah, that's true. I just dabbled in Python, and I was like, I'm going to move on to different pastures, but now I'm back again.
Oh, well, welcome back. Welcome back. It's lovely to have you here. Cool. So, well, lovely to meet you both. And let's see. Is there any... So, yeah, before we actually get to the main discussion, would you like to tell me what projects you've been working on, like, besides the pydata APIs? What is it that it's, like, flashing your eyes with excitement at the moment?
Let's see. Well, I mean, I mentioned NumPy and SciPy already. I mean, that's been a more labor of love. I don't really get to write much code there anymore. It's more review code, help newer people get started. But in the last year, I've also done a lot of work on PyTorch, and we have a 14, 15 person strong team right now working on PyTorch, and that's been a lot of fun actually. So just because I got to learn new things and write a bit of code, and yeah, I've been enjoying that for last year.
Cool. And Athan?
Yeah, at Quantite in particular, I've worked a lot on Jupyter Lab and Jupyter Lab extensions. But in my free time, I write numerical software for use on the web, and I'm a lead maintainer of the open source project standardlib.js, which is a NumPy SciPy equivalent built on native web technologies such as JavaScript and WebAssembly.
Okay, so when you say numerical software for use on the web, what do you mean? I'm sorry.
I mean being able to run to perform numerical analysis or scientific data analysis in web applications or in Node.js. So currently today, you can't deploy Python in a web application, or at least not easily. You typically have to transpile it to something that's web native, such as JavaScript or WebAssembly. But I write a lot in C and JavaScript, and then either compile the C into WebAssembly or write things in native JavaScript, such that you can do machine learning in the browser, such as like real-time object detection or speech synthesis or whatever it might be that you want to do. That way you don't have to have a backend server set up to run analysis. You can do everything kind of pushed out to the edge on a client machine.
That is super cool. I don't even have a follow-up question for that. It's just super interesting. Okay. Any favorite library? Do you have a favorite library at the moment? Any of you two?
Oh, that's a really loaded question.
I know.
All of them are my favorite.
Okay. Yeah, I take that one. It's fine. It's a question out of the script, so I can't expect for much more from you.
No, we have people working on everything, so it's like, it's very hard to grab well here.
Yeah, I'm causing conflict here, because then you answer that here, and then as soon as the call goes off, you go back to the office tomorrow, and everyone is like, "What do you mean this is your favorite library?"
Exactly.
I get it. It's okay. It's okay. Cool. So I guess we should move then into the main discussion. So let's talk about the actual consortium. So we have a few questions here about the motivation, a little bit about the history, the goals, everyone involved in standardizing those APIs. And then I've heard that you two have been involved with it since the beginning, like the inception of the project. So Ralf, could you tell us what motivates forming a consortium around the standardized pydata APIs?
Sure. Well, I guess it's a long story. If you don't mind, I go back to like the far beginning.
Yeah, you can do whatever you want. It's fine.
Okay. So very, very long time ago, actually, when I started writing in Python, there was this thing called numeric, which was the predecessor of NumPy, right? And then there was numarray, which is the other thing that I never really used because I couldn't figure it out. And then, someone wrote NumPy. Travis wrote NumPy to kind of put it back together. And then for a long time, everything was, peaceful in the universe. Right? And then the last 5 years or so, like there was this explosion of like new array and tensor libraries that, TensorFlow and PyTorch and Dask and it all kind of looked alike and stole ideas from each other, but it's also all pretty much incompatible in very subtle ways. So if you ever try to write anything, let's say you start with NumPy and then you move to TensorFlow, and 2 years later you think like, maybe I should move this to PyTorch, you figure out that basically absolutely nothing is the same. And this is a problem. I think it's a problem for end users, but I mainly look at it from a library maintainer point of view. Like I actually spend more time on SciPy than on NumPy. And like we would like to be able to like support CuPy, for example, or support Dask to have like distributed arrays, but it's really hard to do well. So it'd be nice to have this uniform API that kind of brings back together like all these things that are now all subtly different. So I think that's the main motivation. And I think I can hold a similar story for data frames. Like data frames are a little younger and less mature, but you also got like 7, 8 libraries that are all similar, but not really the same. So I think that's what motivated this. And then we started thinking for a while about what's the kind of best way to bring this back together. And I think it's way too hard to write just one library that does everything now. There's just too much innovation going on. So then we thought like we have to figure out what's common and bring back together that minimal set and really just do it as like documentation and maybe a test suite that can be uniform, so you can check that things are actually working the same in all these different libraries. And then started to figure out, like, how do we bring people from all these different libraries together so we can actually figure out what they all need. So that's how the idea for the consortium was born.
Okay. I have a few follow-up questions on that, but Athan, would you like to complement this answer on anything?
No, I mean, I think one of the major goals here is just to kind of like reduce fragmentation. I mean, it's when you are a user and you're trying to move between these different libraries, you have to have a rather complex mental model. You have to understand like how each of these individual libraries like differ. Maybe it's just like the naming conventions, maybe it's the availability of keyword arguments, maybe it's the supported data types. And so it's hard to have all of that kind of stored up in your head. And so if you can have at least a common subset that you can then kind of know or have some kind of guarantees that it's the same across these different platforms and libraries, then you have that kind of common foundation. So it allows you to increase your productivity. It reduces like the mental burden that you have, and you can focus more on the creative aspects rather than having to refactor and reorganize, etc. So hopefully it's a net win for everyone involved. At least that's how we see it.
Cool. Yeah, I completely agree. I am curious now to hear about how is the user research that you're doing for this, because you just mentioned that you're having a look around to see how people are using it and how we can standardize in the best way. So yeah, how is that working?
You did a lot of that, Athan. You wanna?
Well, yeah, I mean, as we identify it, there are kind of like two primary sets of users, and Ralph's already alluded to this. And the first is array and data frame library authors. And for these authors, when we think about the effect that the consortium is going to have on their work and kind of how we think about this, is that we're just trying to bring all those people to the same table so they can either discuss like where they had like difficulties in implementing a particular like NumPy API if you're in TensorFlow or PyTorch, or maybe even the particular concern, so we can have like a little bit of a forward-looking idea of what's kind of like needed for the future and how can we kind of consolidate around the needs of everyone involved. And when we think about the effect of what these particular users, these stakeholders in the various libraries involved, like what we think about is like the consortium will have an effect on what they do, in terms of, you know, they'll want to kind of work toward implementing the standards published by the consortium. They'll want to ensure specification compliance, and they're really going to be working toward that common goal of reducing ecosystem fragmentation, so they can focus more on the things that is kind of more in their wheelhouse, such as particular targeted platforms or particular hardware or particular applications, whether it's deep learning or just financial analysis or whatever it might be. And just to kind of like highlight what a concrete example of fragmentation looks like today, and Ralph alluded to this a little bit, is like, you know, just take a function for computing the arithmetic mean. And while most, if not all, widely used array libraries expose a function for computing the arithmetic mean, which would suggest that somehow the API is like important. If everyone implements it, then you would assume that they've identified that as being kind of like necessary. These same array libraries often differ in their naming conventions, their keyword arguments, and some of these differences are cosmetic. For example, they may name the function mean or AVG or average or reduce underscore mean, and other differences are more substantive due to device requirements, implementation constraints, or some other reason. And so you can already kind of like imagine that you have to have a little bit of a mental model as you kind of like work through that. And so when we think about that aspect, the other kind of like user research is we have to think about the downstream users. And so for downstream users of these libraries, should they want to switch from, say, NumPy to DAS or TensorFlow, they're effectively forced to learn a library's own unique domain-specific language, or DSL. And while these DSLs often share similarities, the differences are common enough and often ad hoc enough to impose a significant cognitive burden and introduce incompatibilities, as users must constantly recall whether a given library supports X, Y, or Z options and particular data types. And so in terms of like the downstream user angle and the type of research that we kind of conduct, is we're really looking to determine like how do these downstream users actually consume these APIs, and kind of like what are their needs? And we do that through various tooling, which I imagine we'll get to kind of later on in this conversation. But one of the things for really addressing the needs of these downstream users through our work is to kind of like reduce this cognitive burden by unifying common conventions around naming, available keyword arguments, supported data types, and implementation behavior. And the hope is that by reducing that cognitive burden, we'll reduce library friction for library consumers, allowing them to more readily switch between libraries depending on their use cases and constraints. And the one thing about this is that this should have the added benefit of reducing code complexity and reducing the need to write kind of complex conditional logic for handling the eccentricities of each library. So if you're scikit-learn and you want to be able to consume different array types, it's quite difficult because you have to kind of know what you're getting, the kind of like object instance, and then you also have to figure out like, okay, well, I want to compute the arithmetic mean, but I need to use this other naming convention for this other array library. So you end up having kind of like complex conditional trees, which no one really wants to maintain that. That's just kind of like a maintenance burden. And so hopefully we can kind of like reduce that by kind of that complexity by having that common subset and reducing the kind of like the scope of eccentricities. We won't be able to eliminate entirely the eccentricities of each library because they're needed, but hopefully we'll make dealing with them more manageable. And I should also state that library authors also stand to benefit from reduced friction for two reasons. The first is that the reduced cognitive burden means that, for example, NumPy users will be able to more easily grok and use TensorFlow, Torch, Dask, or some other array library and vice versa. And thus the potential here is that they can expand their library's potential user base. And the second benefit is that by adopting the standard rather than reinventing the wheel, often in an ad hoc manner, library authors can focus instead on the important differentiating aspects of a particular library. For example, a library's target hardware or its target applications. So in summary, it's our hope that the consortium has a positive effect on the pydata ecosystem by promoting better compatibility and interoperability between and among array and data frame libraries, which we believe is a net win for both library authors and downstream consumers.
Cool.
Can I add one small thing related?
Absolutely.
You said user research, and the first word that came up for me was telemetry. Like we have been talking in this, with many of these projects for a long time about how do we get better user data. And I think even back in 2012 or so, like there was some NumFocus effort started to think about and build tooling for telemetry. Never really got anywhere, and it's a really hard problem. And in the meantime, like there have been multiple approaches doing like static analysis of code, but it's always like limited what you can learn. Like you can write some regular expressions and figure out what functions are used, but then like how indexing is done, or how what keywords are fed to what functions and what types those inputs have is really hard. So I think the tool we have built and now released as a separate project to where everyone can run, it's not even specific to NumPy or Pandas, but everyone can use that tooling to run their own code and kind of exactly figure out what API service you use and with what input types. And I think that's a really cool project by itself.
Yeah, that sounds really interesting. Absolutely. Yeah, like being able to touch on that is already a big challenge. So if you can find any way of just like trying to mitigate that issue, yeah, wonderful. Yeah, and that's the reason why I asked the question as well. How are you doing user research for this? Because I know that is a very challenging part of doing research in general when you're trying to standardize things.
Well, I mean, you have two aspects to this. One is you have the user stories, and you have the user stories both from the author standpoint in terms of what are their end goals, and then you also have the user stories from downstream users. And so part of the consortium is getting a lot of the user stories for the array and data frame library authors, kind of like what are their needs, and that's kind of what I alluded to. And then there's very much the real aspect of what Ralf was talking about is the kind of like the telemetry data in which we're able to better understand the kind of like surface scope of actual usage. Often when we think about like popularity or usage, we rely on kind of either ad hoc or kind of like guesses in terms of what's important. Or maybe we'll look at like download counts, but it's really hard to get fine-grained analysis. And so part of the work of this consortium has actually been building tooling to allow us to access that telemetry data to make better informed design decisions.
Okay, so quick follow-up question on that is that telemetry, are those telemetry tools going to be open sourced as well?
Well, they currently are open source. In fact, much of what's currently open source from the consortium is entirely tooling. Tooling for comparing array and data frame public APIs, tooling for quantifying how frequently array and data frame library APIs are consumed by downstream libraries and consumers. And soon we'll have tooling for testing specification compliance. I mean, if you want, I can speak about each of these kind of like in turn, but I mean, it's as Ralph mentioned, like this has been really critical because otherwise we'd really struggle to understand, and as you kind of are alluding to, is that really understanding the commonalities and differences across these libraries and really understanding what's important. So the tooling, which is already open source and what people can already run, if you go to the GitHub organization and you look at the data APIs organization, you'll see that there's various tooling repos that we've open sourced, including with the data that we've collected so that people can run their own analysis, and even some Jupyter notebooks that kind of like dive into a bit more how we think about the process and how we think about kind of like narrowing the focus and the scope of what we want to try to standardize. So all that stuff is currently open source, and the idea is that moving forward, we'll continue to release these any of the work that we do as part of the consortium as open source under a permissive MIT license that people can, which means that people can easily consume this and also contribute back to it if they want to.
Thank you. Would you like to add anything to this, Ralph, or are you good? Shall we go to the next question?
I think that was a good summary, and I think it's like I would encourage like library authors to look at this, because I'm often pointing people to it already. Like every time we have a discussion, like, you know, is this function more important or that one, or, you know, can we deprecate something? It's like, oh, let's just look at that data because it's like right there, just in CSV files or JSON files. So you can see, like, you know, whether it's SciPy or Xarray, or like, you know, how often they use this stuff.
Yep.
Yeah, I mean, as an author, often you really just don't. I mean, you have a lot of your own personal hunches and biases in terms of what you think is important, but you really have a very loose grasp. Maybe it's kind of anecdotal about what's actually used and what's important. So there's a lot of things like historically that are in NumPy that maybe it's questionable whether it should actually be there. And is because NumPy captured a lot of market share and was kind of like the de facto standard for so long, what we've seen is that these new crop of libraries that have come into existence have simply parroted a lot of the APIs on NumPy, even if those things are either obsolete or not applicable, or in hindsight were maybe a little bit ill-advised. So by having this telemetry data, it allows authors to kind of really be able to answer questions about what's important, how frequently are things used, and what does that mean for a library and API's lifecycle going into the future.
That answers a question that I received a few times when I was chatting to people about this. There was why to do research then to develop a project like this? Why not just choose one? Would have been much easier to just get one and then design everything around that.
Well, maybe not, because the reason why things are not the same now, they're, you know, it's not just completely arbitrary, right? It's, for example, like, you know, give one concrete example. Like if you look at, you know, the NumPy array attributes, like a shape or a size or something, right? They typically give back like a Python integer or a tuple. Now, if you build something like TensorFlow that has like delayed evaluation and builds up this whole graph of computations, you can't really do that, because if you want to return a Python integer or a tuple, like you kind of force the, you know, you kind of break the delay of the evaluation. You have to evaluate up to that point, right? So rather, you know, TensorFlow doesn't do that. It kind of gives you back some kind of more abstract object that kind of acts like a tuple, but can keep the whole thing delayed, right? And it's the same with, like, most libraries chose to do only 0D arrays, but not array scalars. and lots of these choices, they kind of have been made ad hoc, but usually for good reasons. And now we kind of go back and kind of figure out like why do we have these incompatibilities, and why have people made these decisions, and can we kind of now come up with a final choice that works for everybody?
Okay, it makes complete sense. Thank you so much for clarifying. Thank you. Awesome. So I want to move then to talk a little bit about the other people involved on this, because this is a very challenging project, and I heard that there are a few other organizations involved on this. And I would like to know who they are, like in general, and how is it work? How is the team working, kind of like being done, and also, is it beneficial to have that many people working together doing that? Is it not?
Well, it's actually kind of a minimal group. So, our goal when putting it together was basically get 1 or 2 representatives from every array, tensor, and data frame library. So that's already like 16 libraries. So, and then, it's a significant amount of work. So we also needed some people to actually fund some time, because there's only so much you can do like in your evenings. So we have at the moment, next to so we kind of started this from Quantsite, and we so far have 4 external sponsors. So that's Intel, Microsoft, Google Research, and Dijon. So most of them like have very clear interest in this. Like either they have an internal data frame library, or they just want a uniform API so that they have a smaller target to accelerate, or there's something in it for everyone. But basically, like we kind of pulled that group together, starting in May or so. So maybe started 5 months ago. And of course, it took a while to get everyone together and figure out really what we're doing. But because we're trying to tackle such a complex problem, we figured we needed to start with that as small a group as possible, but making sure like all the stakeholders had at least 1 representative, and kind of at least come up with a coherent story that then can be understood by a broader audience. So, and at that point, we wanna release it. So, this quite some thought went into this, but like there's 2 things you can do, right? Like if you look at most standards organizations, they actually they completely pay to play, and like even the standards themselves, like the PDFs, you have to pay for. Like that's definitely not going to work for this community, right? We want things to be open source, and we want everyone to be having as easy time to adopt it, but also to get insight in the whole decision-making process and figure out who does what and why, right? So, but on the other hand, like if you start like, let's just make a repo and do everything in public and just talk on a mailing list and GitHub, which is traditionally what people have done, then it's just too hard a problem to come to a coherent solution. So we wanted people who come to like a call every week and at least spend like 1 or 2 hours, so that we can build up the shared understanding and come to an initial draft spec that makes sense and is complete enough to present to the whole community. And that's kind of where we are at now. So we have this group, it kind of working well, like the array and tensor spec is kind of getting to the point where it's close to being ready for a broader review, and then the data frame spec will come a few months after, I'd say, because that's a harder problem.
It's okay, we trust you. So basically what we're doing then is keeping everything closed off and private until it's actually done like bare bone done for testing, and then people are going to be able to contribute to it.
Yes, exactly.
Okay.
And we're trying, like, this is a hard problem, and we're trying to get this balance right, because we also don't want to like keep the conversation till it's like a nice polished, completely finished spec, and it's like, here you go, like, take it or leave it. Like nobody likes that, right? So there's enough to-dos and decisions to make that when we open it up, like there will still be a real conversation and a real, change of direction possible.
Cool. Just making sure that everyone has a voice. Very good. Would you like to add anything to this, Athan?
No, not really. I mean, only I would say is like when we think about initially creating the draft, if you have too many kind of cooks in the kitchen, it can lead to a bit of chaos and just kind of like organizational mess. So by having kind of like a little bit smaller group to kind of like seed the specifications, it allows us to move quickly, as well as to kind of be able to survey kind of a representative landscape of kind of the needs and create those user stories, so that we can make sure that what we do put out there as a draft for comments from the general public, that we've created something that more or less addresses the high level points, so that we don't get bogged down and kind of like endless back and forth or kind of like theoretical conjectures. We were able to kind of like have things streamlined and to make sure that we're able to kind of like move forward relatively efficiently.
Yeah, because that was exactly the reason why I asked this question initially, because when I saw the banner with the amount of companies that were all contributing to it, I was like, well, there's probably someone from each one of those companies in there. And then you have, well, if you have like a core team for the library, can be like, they said that the optimal team is around what, 7 to 10 people, is that it? Something around those numbers, like 5 to 10 people, I think. And then if you have 100 of them, if you have 60 libraries, and then 2 per each, and then so that was the reason I couldn't understand how the communication was flowing.
Yep, we split it already and like separated out arrays and data frames, because in the beginning when we tried to figure out what we're doing, it was kind of common, because we want these things to be to look very similar, just have like different specifics for arrays and for data frames. But now that we're actually talking about the specifics, so like so we have like a one call for arrays, and then the next week we have calls for data frames, and then in between we have people with enough bandwidth that can kind of summarize everything and kind of seed the discussions.
Okay.
And membership isn't necessarily fixed. I mean, it's part of the governance document and the consortium structure. Like, we certainly envision that this consortium hopefully will continue to grow and bring in more key stakeholders, companies, and projects. It was just important for us to currently just work on what we kind of like intuited or kind of researched as kind of being representative of the various use cases of the current landscape.
Well, I would dare to say that, considering that the choices of library you've made and the companies that you've chosen to be beside you, even if that was not a conscious choice, I would say that that's already a determination of how much of a standard it will be. So the use cases that you have there are already demonstrative of the real use cases that we have around, because, well, that's the use case. They're big companies, and they're big companies, and everyone uses those libraries. So, and again, if you're wrong, you can just leave issues on GitHub. So.
Exactly. I'm sure we're wrong in a few places.
Okay, well, thank you. And then if people would, I mean, we know that the tools are already there, open source, and ready to be had a look at. But if people want to contribute to things, is there already anything that is already there that is open for contribution, or is coming soon?
Well, I mean, much of anything that's any of the tooling which is open source and publicly available now is, of course, people can start contributing to it. It's under an MIT license. Otherwise, we have an issue tracker for gathering public feedback, which we've already started receiving like comments or suggestions from people outside of the consortium. So people can go ahead and comment there. If on the blog post that Ralf published on the dataapis.org site, there's a link to it. So if people have like ideas or suggestions or concerns, like there's something there that they'll be able to voice their concerns. And of course, if you want to provide your feedback and opinions, we're always available on Twitter, for better or for worse.
Fun.
We love Twitter. All devs love tweeters, and all maintainers love tweeters even more. Yeah.
Yeah, I have to say I was pretty happy with the initial feedback. Like some very good ideas were already contributed. Like from the the DLPAC tensor exchange, data exchange protocol to like an improvement on possible improvement on the out equals keyword. Like, so far it's been pretty good.
Good. And then do we have a timeline for achieving those goals? I mean, when things are actually going to start getting out of the private repos?
Yeah, so I would expect, I mean, the blog post said 15th of September, but it's 2020 and everything's going wrong. So if you say September, it's definitely going to be October at least. So, but the array spec is very close to ready. Just Athan should kick me a little bit so I do my part because he's almost done. But I would expect, within 2 weeks or so that we can publish that. And then probably another, it's hard to say like how that's going to go, but I would expect another 3-4 months or so, like, of several iterations before like, we've gone through like a full review and fixed up all the to-dos. So hopefully like maybe the end of Q1 next year, we have something that's a final spec for that. And then of course, all libraries will figure out like they're mostly compatible, but like in lots of little places they aren't. So then there's a lot of technical work to do. So before we have the first libraries that are like, 99% compatible, I don't know, maybe a year.
Okay. And would you like to elaborate on the critical needs for success, then Athan? I would show this to you.
Well, I mean, as with any consortium, and as Ralf alluded to in the blog post, a specification is only good if it's adopted. So one of the critical things that we need to make sure is that we continue to engage library authors and key stakeholders to make sure that the specification is actually satisfying real needs and satisfying the general use cases that people have. And hopefully through our conversations and the feedback that we've gotten, we're doing that. It's just we need to make sure that we continue to do that, because if at some point people say, well, this standard really isn't worth anything, we're not going to ensure compliance, we're kind of back to square one in terms of fragmentation, et cetera. And so, you need to have actually adoption from the array and data frame libraries. You need to have community buy-in. You need to have continued support from the community to clamor for the need for this and to kind of like voice their concerns and their feedback. And then we need to continue to stay relevant, meaning we need to ensure that this isn't just a one-off thing. We can't just have like a standard publish at 1.0, walk away and claim our job's done, because what the past 5 years has really taught us is that new types of hardware, new concerns, new use cases will continue to arise, and there will be new things that we need to standardize, new kind of like common use cases, et cetera, that need kind of consolidation to, when we think about this as kind of like a rubber band effect, where you have over time, you have the rubber band kind of like expand, you have fragmentation, and we want to like bring that back so that people can once again focus on those key differentiating aspects, such as their target platforms, their targeted use cases. So we'll need to continue to evolve this standard. We'll need to continue to make sure that we're addressing the future needs of both authors and downstream users.
Wonderful. Thank you. I think someone would like to add something? Someone would like to say something? I think there's someone raising a hand.
Yeah, there was a question from the audience. The question was, what are some of the things the data API consortiums has learned about the different between arrays and data frames? On the surface, they seem similar. What are some of the key separations there? Sorry, I'm having a lot of audio feedback, and it's like tripping me up. Should I repeat the question?
No,
we got it.
Okay. Yeah, okay. We got it.
I don't know. Arrays and data frames are similar. They can answer the question. I don't think they're similar at all.
Well, I mean, I guess like in kind of like broad strokes, like what we see is that in the at least the maybe array world, we've seen maybe a little bit more divergence. This is true. Like a little bit more divergence maybe from NumPy because of the different use cases and the targeted hardware platforms, device support, etc. So while NumPy has kind of been the de facto standard, and many people, there are initiatives out of Torch and TensorFlow to kind of replicate a lot of the NumPy API, we still see that there are kind of bespoke use cases. A lot of the signatures are different, etc. And the Pandas world, the data frame world, what we see is many libraries really try to stick to whatever Pandas does. So whatever keyword arguments, if for like read CSV, Pandas has like 120 different keyword argument options. And so, data frame libraries will basically say that, well, we need to replicate that entire thing. And so there's maybe a little bit more adherence to kind of the de facto reference implementation in the data frame world than in the array world. It's also the case that the array world is maybe the ecosystem's maybe a little bit simpler, a little bit more tractable in terms of the specification process and kind of like we kind of know more or less the use cases, the concerns, and kind of the future evolution of where things may be heading. With data frames, it's a little bit more of the Wild West in terms of really pinning down like what's essential, what's not. The scope of the Pandas API is absolutely huge, whereas let's say NumPy array API is a little bit more constrained. We're looking at maybe a couple hundred methods, whereas like Pandas, there's like 1,000. So like the use cases and kind of like scope of data frames is broader and more encompassing, a little bit more unwieldy. Whereas in the array ecosystem and with these libraries, we're dealing with a little bit more of a tractable problem that has a bit more of a defined scope. I'd say those may be the similarities and differences that we're seeing right now.
Yeah, maybe I'd add like data frames have a much bigger divergence between what library authors want from them and what end users want from them. Because if you look at arrays, like everyone just uses a functional style, right? And focused on performance and knows how to do indexing, etc. While data frames for interactive use, where you basically just use methods and would like to just chain them all together, can be very different from when you build a library that you want to be performant. So I think there we make more a conscious difference between those two groups of users and kind of focus more on the library author use case first. And the other thing there is that the number of data types is much less well defined. Like it's broader, like strings and categoricals and NA values. So it's less mature and broader, which makes it a harder problem.
Okay, thank you for that. That was a great question, actually. Do we have any more questions from the audience? Let's see.
No, I think that was it. That was it. Yeah. God, audio feedback sucks.
Oh, well. Okay, perfect. So I have then one question for you. So actually I have two. So the first one is, so Ralf was talking about, when we were talking about the different companies they're involved on it, you said that, well, there is something in it for everyone. And I would like to know then for each one of you, what is it that is there for you personally? So Ralf and Athan.
All right. So for me, I would say I unfortunately don't get to use much anymore. Like I don't get to analyze any data anymore. I just write library code. So, but as a SciPy author, like for a long time, we've had on our roadmap to support distributed and GPU arrays. It's one of the top items on the roadmap, and it's something that a lot of people are interested in. But given like how limited our resources are, like we're never going to have like CUDA code inside Pi, for example. That's just not going to happen. But on the other hand, like if we could accept like, you know, a TensorFlow array or a CubePy array, that would work really well. So, but you can only do that when they have an API that is kind of the same as with NumPy, right? So we have to have like, and we have to have a way to know that it works. We can't just say like, like in the next release we support CubePy and like good luck with it. Like, because we, you know, we need to be able to have like some trackable target that we can test, that we only use like, let's say the functions and the properties in that API target, so that we can be relatively confident that, you know, this will actually work. So that's my main personal driver, I would say.
Okay, so it's an old project that you really, really, really want to get it done, and it needs this extra bunch of work to actually get that done. Okay.
Pretty much.
I mean, among other things, but okay. And then Athan, what is it in for you?
I think that in my personal experience, I deal a lot with kind of CPU-based numerical computing. So this is really an opportunity to take a step back and understand kind of the broader concerns of how these different libraries are addressing key problems or maybe emergent hardware stacks, et cetera. And so it's been great to interact with a lot of the key developers and stakeholders of these various libraries to kind of like understand like what are their concerns. Like if you're thinking about API design now, and you were to do this kind of like from first principles, like what would be the concerns that you're kind of like thinking about? What are the kind of like limitations? And so I think it's been a very good broad exposure to a lot of these concerns that you wouldn't necessarily get if just as like an outside consumer or user or someone that's focused on a particular type of hardware application, which is what I do. So in that sense, it gives you kind of like maybe a bit broader perspective in terms of like if I was to go and start designing, like say an array library API, what would be the concerns I would need to think about in order to ensure that this is more future-proof? What are the mistakes that, for example, NumPy maintainers and authors made that they wish that they could go back and change? You know, that's all very valuable. And so I think it's been great from that perspective to get that information and be able to synthesize that and create something that's a bit more forward-looking.
Are we going to get a guide on how to make proper software for the future coming out from this as well?
I
don't know. We'll see.
Well, I mean, okay. I would say like that is maybe part of it. Like you see many people in other languages, you know, copying, like they usually say that they copy NumPy, but it's like, you know, Python is where a lot of the scientific computing and deep learning, etc., is happening, right? So you see people copying NumPy or Pandas or TensorFlow, and usually they just look at it from a distance and just copy the parts that they like, right? Which is a little inconsistent. So I think from that perspective, like that group of developers for other libraries could have a consistent story and API to copy now.
That's correct. Yeah, certainly.
Can I also ask, Lais, you were very enthusiastic about this. Like what, you know, when you first saw this, like what was your driver to like want to know more?
Okay, so initially, the first time I saw this was when I was starting to interview for Kedro. So I was trying to understand what good things could come of standardizing a library or any piece of software to work on a team. So I was thinking about what you're doing, but I was thinking in a much, much, much smaller scale. So how would you do, for example, if you're working in a team of data scientists and then you have a few data engineers and then a few machine learning engineers and a few technical editors as well, how are you going to make sure that all those people work together in a standardized way to produce good quality software, to produce good quality documentation, in short, to do whatever it is that they do the best way that they know how to do it? And then when I was like doing a little bit of research, and I saw that there was this consortium to standardize Python data APIs, I was like, wow, this is exactly what we need in the data science world right now, because we have Facebook producing XYZ, doing with like these APIs that really you fit really well, but fit really well their specific use cases and what they're doing in their own products. And then if you try to use that with some of the libraries that Google, for example, produces, you're like, well, how do I put those two together? So that was the thing that got me really, really, really excited about it, because I believe in a world where 3 operating systems can talk to each other.
That's a nice goal to have. We have a long way to go.
I know, but we get there slowly. Yes. Does that answer your question? Is that?
Yeah, definitely. Like, and I think, yeah, that's a good motivation. I think a lot of people in companies have that much, especially in companies, maybe also in research groups. But I think especially in companies, when you have a bunch of legacy code and like a few years later, a new group of people comes along and write, they have their own preferences and they choose their own libraries and frameworks to work in. And then group number 3 comes along and it's responsible for putting it all together and making it work in production. And like, good luck.
Exactly. Yeah, that's exactly the point. Absolutely. I have one more question, but I don't know if we have time for it. It's a short one. Do we have time for it? Maybe.
Keep going. Keep going. Cool. The end of this is so good.
So my last question for you then, for the both of you, is, well, what would be your main advice then for someone starting an open source project right now? Not necessarily based on if it's community open source or if it's enterprise open source, just what is it the one thing that makes it fundamental to be good?
Ooh, that's not a short question.
Sorry.
But it is a very good question. Like I actually did think about that fairly regularly. And to me, I think one of the most important things is like, besides like having an interesting problem to solve and, starting from the beginning, doing everything like with a lot of care, like, writing code that doesn't accumulate a lot of technical debt, that is well documented, that's well tested, but also being really careful about your API design. And I think at least in the pydata world, I think scikit-learn has set a really good example there. Like they've been really careful with, having consistent APIs and being very conservative in like adding new things. And now it becomes very easy, it has become very easy for other projects to write scikit-learn compatible APIs. And I think, I would always appreciate that, but especially having come into NumPy and SciPy after they were created with basically like almost no tests and very little documentation, like spending the next 10 years kind of fixing it up, like I really appreciate it.
I can only imagine. And then, Athan, would you like to tell me what is it that makes a good open source project for you?
Well, I think one is that like when you're initially starting it, I think you, well, on an individual level, like it's very important that you have a certain amount of grit and perseverance, because like the road can often be quite lonely and a little bit desolate, and you often have to plow through things. Anytime you're trying to do something that's relatively ambitious, it's going to take a lot of like work and often non-compensated work. I mean, you have to have a certain kind of drive and love for what you're doing. So cultivating that kind of like tenacity or that perseverance is quite important. I would also say that it's important to assemble at least a small community for yourself. Maybe that's having other developers that you can work with, such that you can bounce back ideas and have sanity checks and to also have encouragement and kind of like pushback on your ideas. So that kind of that duality, that dialectic, you need that process in order to produce something really good. The third thing I would say for individual contributors is that I think it's very important that you take kind of like the Etsy manifesto, which is having code as craft. So that's taking really great pride in creating really high quality software and really trying to do things as best as possible. That means like testing, that means documentation, that means benchmarking, that means examples, like really thinking carefully about what you're doing, to build on what Ralph said, and to making sure that what you're doing is kind of trying to create the highest quality product that you can. Because it's an enormous amount of work to kind of go back and redo things and to make things polished. And if you rush through things and you make things sloppily, or you don't take a lot of great care, you end up making a lot of design decisions that you end up later regretting. And you want to avoid those things. And I would say like the last thing is that at some point, in order to be successful, you're really going to have to do a lot of community work. You're really going to have to do a lot of liaising with your end users, with other developers, to really understand their needs and their concerns, and either why they're using what you're using or why they're not using your product. And so you really need to have that kind of like feedback loop. It's very easy for an author to kind of like silo yourself away, be up in your ivory tower and not get really any good feedback. And you run the risk of kind of meandering in the woods for a really long time and then coming out and there's no one there to receive your work of glory. So you really need to make sure that you're always engaging with community and trying to build momentum outside the larger community, because it's really those network effects that's going to drive the success of your project.
Those are great. Like I don't even know how to say thank you.
I have so many chills. I'm so glad that ran over. Thank you all for staying late.
Thank you. Thank you for answering all the questions, and thank you for dedicating your time and your brain to this task.
You too. This was a really fun conversation.
Yeah, thanks for hosting.
Thank you for coming and answering my questions.
Yes, and thank